So, uh, we are given with n, and n lies between 500 and 1, and we need to find number of subsets, right? The number of ways the numbers can be divided into two sets of equal sum. Number of ways. We have to find the number of ways such that the sum of the two subsets is same. So, okay, as the n is less than 500, we can get to a time complexity of n cube also. This also works. Um, okay. So the maximum sum that is possible is 500 into 501 by 2, which is 250 into 501, which would be less than 10 power 4. Or let's take, for example, 10 power 5. Okay, this will be less than 10 power 5. So, for this, we can do this. Okay, we can we can find all the sums possible, and then number of times half the sum is formed by 2. That means, for example, if in the question the example given was n, 1, 2, 3, 4, 5, 6, 7. These will be the numbers. So the sum of all these numbers is n into n plus 1 by 2, sum of all numbers. So that would be 7 into 8 by 2, which is 7 post 28. If this number is an odd number, if the sum is an odd number, then we can't form equal sum. So the number of ways would be 0. If this sum is even, which is the case, then uh, for having two subsets of equal sum, every subset should have half the sum, right? So two subsets with 14 and 14 would be there. So here we have to find number of subsets with sum 14 by 2. So this would be the answer. So to get the number of subsets with sum 14, we can do this. Correct. Why is this not moving? So we take every number for I equal to 1 to I less than or equal to n I plus plus. We take every number and we take for all the sums already formed. So all the sums already formed. We would find the sums formed by adding this number. Okay, then okay, first the sums that are possible is 0 to n into n plus 1 by 2. First, all the sums is false. All these numbers, no sum is found, so that will be false. But then, as we get 1 will become true. And then as we get 2, there is 1 is already true. So 1 would be true and 2 would be also true. And 1 plus 2, 3 would also become true. When 3 comes, 1 is true, 1 plus 3, 4 would be true, 2 plus 3, 5 would become true, and 3 plus 3, 6 would also become true. So for all the sums that were already there, we add the new number to those sums and we will make them also true. So in this way, we can find all the sums possible and we can check the number of times the sum 14 is formed or n into n plus 1 by 2. That is the total sum and total sum by 2. We can check how many times that is formed and that would become the answer. So the time complexity would be, so the DP table would be of DP is it that can be of 2D vector, but then we can do space optimization, which then would become 1D vector only. Then it would the time complexity would be of big of NQ, which we can do according to the constraints that we were given with. So let's code this now. Input is just the number and we can print the module answer modulo 1e9 is okay. Let's take the input. Sum equal to n into n plus 1 by 2. Okay, okay, let's declare this int. So if sum and 1, that is the sum, if sum is odd, we can print 0 and then return else. We don't even have to write else because we use the return statement already. Vector in DP sum plus 1 comma 0. Let's take DP of 0 equal to 0. So for in we should also take a temporary array vector in left sum plus 1 comma 0. Okay, for int I equal to 1, I less than equal to n, I plus plus. For int j equal to 0, j less than or equal to some j plus plus. If dp of j is not equal to 0, then hmm, temp of j plus I equal to 1. We can do this. Well, in j equal to 0, j less than or equal to some j plus plus. If temp of j equal to 1, dp of j plus plus, and then temp of j equal to 0. Okay, we reset and sum by equal to 2, c out dp of sum by 2. This would be the answer. Let's Mhm. Array, why did I keep this 0? I have to keep that one. Okay. We have to find the two sets of equal sum, right? Two sets of equal sum. So yeah, some Mhm. If dp of j is not equal to 0, temp of j plus I equal to 1. If temp of 1 becomes 1, and then temp of j equal to 1. Hmm. Okay. What are we doing wrong here? Let's print and see what's happening. Okay. Sure. Where are we getting one as answer when it should be four? As far as you know, what I did is correct only. We we are finding all the sums that can be formed, and then we are doing the total sum by 2, and the number of times just total sum by 2 is formed, we are printing that by 2. That would be the number of ways which the array can be divided into two sets of equal sum, right? Let's go. Okay, 1, 3, 4, 6, 6, 10, 14. Okay, got it. Okay, okay. So if dp of j not equal to 0, then this should be equal to dp of j. Okay, if temp of j not equal to 0, then dp of j equal to dp of j plus temp of j. Okay, now this should work. Now this is working. Yeah, let's print this which I printed for. Let's comment out this which I printed for debugging. Yes, this did work. Now let's take into account about this. This may, yeah, this may overflow. So let's take the modulus of this. Yeah. Okay. Now let's submit. Wrong answer. Yeah. Why are we getting the wrong answer here? Array. Maybe this is because of this. We are taking the modulus and then divide. We should take modulus inverse, I guess. Yeah, we should take modulus inverse. I'm so sorry because I don't know. We use maybe Fermat's little theorem or something, which is I really don't. I really don't remember because that's been many days I did that. Modular division. Extended Euclidean algorithm. We can take this. Mod divide. This is the formula. AVF. Let's copy this. Let's paste this here. Let's do this. Hash define M mod. Okay, now we should be able to mod divide ABM. So let's do mod divide. What is the function? Mod divide dp of sum 2. Yeah. Now this should work. Let's check for 499. Okay, what is that? We got 60 something, right? Let's check. Maybe that's the problem. I'm 99% sure, but not really. I can be wrong, but I'm 99% sure. Yes, we got the correct answer. We can now submit. That's it. Yeah, really have this. Yeah, let's go. This question I tried to solve in the morning. Then I got an approach in my mind, but that is not related to DB. That is a monotonic stack approach. So I'm not sure why this problem is given under DP. What's the approach that I got into my mind? Let's discuss. So the question is, there are n mountains in a row, each with a specific height, and we begin hang gliding from some mountain. We can glide from A to B if B is smaller than A, and all the mountains between A and B are also smaller than A. So we have to find the maximum number of mountains we can visit on our route. So yeah, this is a basic uh, monotonic stack problem as far as I found it. So for suppose there is an array given. What is that array? Let's copy paste this. Can we paste? Yeah, array being paste. Nice. Can we move this? Yeah, we can move this also. Nice move. Yeah, so here is the question that we were given. Can we zoom it also? No. We can zoom in. Okay, no problem. So we can go from A to B if all the elements between A and B, including B, are less than A. See, you're fine. Are you able to relate it to monotonic stack? First, one thing here, one important thing is we can glide to the left or to the right as well. Yes. So, when we are going, for suppose 2, 3, 1, 2, 1, 4, let's say 2, 3, 5. Here, can you see? We cannot glide from 2 to anything because the number next to it is greater than it and there are no numbers before it. And from 3, we can glide to 2 as well. And we can glide till 1 because all these numbers are less than 3. And from 4, we can glide till 2 and we can glide till 3 to the right. And from 5, we can glide till 2. So you see, we have to find the greatest number, next greatest element. This is a classic monotonic stack problem. We have to find the next greatest element. We should store the index of the next greatest element, sorry. We should store the index of the next greatest element. Next greatest element to the left and to the right. We have to perform the monotonic stack 2 times. First one from left to right, and the second from right to left. So in that we can take the maximum, which would be the answer. So let's try coding this. Let's try coding this. Okay. Input is the number of elements and the elements. As the n is 2 into 10 power 5, we can only do n log n or big of n operation. As we're using monotonic stack, this would be big of n time complexity. Okay. So stack, we should store a pair, one for the number and the other for index, right? Let's store ms. Let's name it ms. Okay. What are the operations that we can perform on stack? Stack dot push, stack dot pop, stack dot top. Okay, these three are enough. Or stack dot empty. Okay, so for int I equal to 0, I less than n I plus plus. If not stack dot empty. If stack is not empty, then acha, we named it ms. Let's name it st only, which is easier. The stack is not empty. Then auto A equal to stack dot top. Let's take the top element. In element equal to A dot first. In index is 1 minute. A dot second. And then if n- greater element found equal to false. This is false, this will become true. Okay. If element is greater than array of I, we should store the answers right. Vector in greater element index n comma minus 1. Remember, greater element index equal to index. Okay. Okay. And let's make greater element found equal to true. Okay, fine. Mhm. Stack, if stack is empty, stack dot push. Let's make a pair. Make pair what? Array of I, comma I. Okay. Yeah. And let's continue. Okay. This is it. And yeah. Let's do the answer calculation also here only. Or we don't even have to store this greater element index. Answer equal to 0 instead of pushing this. Answer equal to maximum of answer comma absolute of I comma minus 2. I plus 2. No, no. So equal to maximum of answer comma absolute of I minus index, right? Yeah. We take the same and we reverse. I equal to n minus 1, I greater than or equal to 0, I minus minus. What is that we can do here? This is 0, 1, 2, 3, 4, 5, 6, 7, 8. This is 9. This is n, let's suppose. The number of elements here is 9 minus 5 equal to 4. N minus I. There would be I plus 1 elements before. So n minus I plus 1 we have to do. So n minus I minus 1 would be n minus I minus. This is I minus n. This is okay. C out answer. Okay. This should work fully. Oh, okay. Arey, we are not doing stack pop ray. Sorry. Okay, now this should work. Again, we got symptom. How is that even possible? How? Acha, if we didn't, hmm, the first element is you had to find the greater element, right? All the element less than that, we can pop. If the element is greater than that, we can't pop. If it is less, then we'll push. If it is already greater, array, 1 minute. Let me clearly think. What do you want? If the top element, okay, if 2, 3, 4 is there. For 4, this is 5. We need the fifth index. So first, if the stack is empty, we would push 5 comma 0. 2, 1 is there. We want 2 also. Okay, if the top element is greater, then we take that and we push this also. We push 2 as well. But if the top element is less, then we would pop. If the top element is less, we would pop. If the top element is greater, we would keep this and we would push this. Yeah. This is how the monotonic stack works. If the top element is, if stack dot first is greater than array of I, then answer equal to maximum of answer comma absolute of I minus stack dot top dot second. Okay, and we push this stack dot push array of I comma. Okay, great. Else, let's do continue. That would be easy. Okay, not stack dot empty and not greater element form. Let's do make pair. T and stack dot top dot first is less than array of I stack if stack dot empty answer equal to maximum of answer comma I plus 1. Else and when we do that, after that, should we push up? We will push right. Okay, improvement. At least we are not getting sick term. Let's check what's the matter with this. Okay. Array. Okay, got it. Let's, after completion of this, let's do this. While not stack.empty, we would pop this. Yeah. Now we should get the answer. Oh no. Mm. And we have to do answer minus one because we just need the between elements, right? We got the answer. Yes. Let's submit. What? Wrong answer for everything? Wait. What? Why am I getting wrong answer? Why? Why? Taller than, if A is taller than mountain V, taller. How is this wrong? How is this wrong? Sure, let's revisit the question. Maximum number of mountains you can visit on your route. There is a lot of difference here in the what? Okay, maybe I interpreted the question wrong. I don't know. I'll check this question later. Okay. What is the next problem? Increasing subsequence. This I've done very before, so let me do this again. We're given an array containing integers. We have to determine the longest increasing subsequence. Okay, for getting the longest increasing subsequence, let's see the time complexity that we can do this with. Big of n. So we can find the previous smaller element, and by using that we can do this in big of n time complexity. We can store the previous smaller element. For this we can use the monotonic stack again, and we can write the normal DP equation. Monotonic stack, we have to store the previous smaller element. So let's do the reverse operation. If it is less, let's do the same. Okay, we have to do this. Just array. We have to store previous smaller element index. For that, um, we can use monotonic stack. Let's see. For suppose there are numbers like 3, 4, 5, 1, 2, 6, 7. For 3, the previous smaller element is -1, and for 4, it is 3. So we store 3, 0, and as soon as we get a bigger number, for 4, it would be 0, the index of 3. And if we get a bigger number, we have to store that number as well, 4 comma 1. Because for 5, if the stack dot top element is less than 5, we can store the index directly. And as the element is bigger than 4, we will store the 5 as well, 5 comma 2. And then we get 1. the previous smaller element is the stack dot top is greater than 1. So we will pop this. And the stack dot top, this 4 is also greater than 1. We will pop this. We'll pop this as well. We will store 1 comma 3, and then this element, the previous element is smaller. If the previous element is if the top element is smaller, we push. Otherwise, we pop till we get the smaller element. This is the funda. So let's code this now. Okay. For int I equal to 0, I less than n, I plus plus. If stack is not empty, stack is not empty, then stack dot top dot first, it is less. If less, we push directly. Yeah. Vector in small index n comma minus 1. If stack dot first is less than array of I, then small index is equal to stack dot top dot second. Small index of I. Okay, if it is else, while not empty, while stack is not empty, and if the top element is less, we are taking the element. Otherwise, and stack dot top dot first is greater than array of I. Let's pop. Okay. Okay, we're done with this. After this, if not stack dot empty, if stack is not empty, then we have found the smaller element. So small index of I equal to stack dot top dot second. Stack dot push array of I comma I. Okay, we have to make a pair. Okay. Okay. This is working without any what time limit exceeded, without any infinite loop. So we have stored the index of the previous smaller element. So let's do the DP part. Vector in. We have to find the sequence only, or we have to find the entire elements also. Okay, the number of elements only. If we have to find only the number of elements, that would be easy. vector n dp n comma 0 for in I equal to 0, I less than n, I plus plus. Let's define the dp state. Let's define the dp state. dp of I equal to longest increasing subsequence, including ith element in the subsequence, or where ith element is the last element in the subsequence. The transition equation would be dp of I equal to dp of small index of I plus 1. Okay. dp of I equal to small index of I equal to minus 1, then 0, else dp of small index of I plus 1. Okay, great. We need answer, right? We have to take the maximum of all those. Let's define here only in answer equal to 0. Answer equal to maximum of answer comma dp of I. Okay, fine. Let's print the answer. This should work. Oh, this didn't. Why does this not work? Let's debug. Let's store the small element as well. Elements lie between 1 to 10 power 9. So let's take the default element as 0, which is never the case. When we're updating small index of I equal to this, small element of I equal to stack dot top dot first. Let's do the same here also. Okay. Let's print what was stored. In I equal to 0, I less than n, I plus plus. See out. Let, let's print the element only because element that would be clear. We can see from the input. Okay. Okay, 0. Okay, there is no previous small element. There is no previous small element. There is previous small element, which is 3. There is no previous small element. Array. For this 3, we have to find the longest increasing subsequence where every element is larger than the previous one. So, where every element should be larger than the previous one. So, the previous element should not be equal. The previous element should not be equal. But why are we getting 3 here? Hmm. Okay, we need to include this. Okay, 3 we didn't have. 6 we did have the previous element, which is 3. 2, no previous smaller element. 9, the previous smaller element is 2. For 8, the previous smaller element is 2. Out of all the previous smaller element, we want, right? So, out of all, we can't traverse because the time complexity would become big of n square and then the limit would be exceeded. So we can't traverse through the entire array. So what should we do? So let's think. We have to consider all the previous smaller elements, which increases time complexity. What can be the other way? Stima- I'm not able to think anything right now for this. So let me take a small break and then I'll continue. So until I may continue the stream tomorrow. Okay, bye bye.